We can break down the question of how good a labeler is into how good is the labeler on each of the diseases, here MAS, pneumonia, and edema. Let's look at pneumonia first. Here we can see the label and the ground truth for several examples. We'll first look at two metrics to evaluate the labeler, precision and recall. Precision asks the question, among the positive labels, what is the fraction of positive ground truths? Recall asks the question, among the positive ground truths, what is the fraction of positive labels? We can write down the formulas for precision and recall in terms of the confusion matrix. Precision is true positives over true positives plus false positives. Recall is true positives over true positives plus false negatives. We can compute these four values in the table to compute precision and recall. So let's start with true positives, where the ground truth and label are both 1. We see that there is one instance of that. Let's look at false negatives, where the ground truth is 1 and the label is 0, and we have one instance of that. Let's look at false positives, where the ground truth is 0 and the label is 1. We have one instance of that. And finally, true negatives, where the ground truth and label are both 0. We don't have any instances of that. So now precision is true positives, which is 1, divided by true positives plus false positives, which is 2. So we get a precision of 0.5. Here we have true positives, which is 1, divided by true positives plus false negatives, which is going to be 1 plus 1, 2, and this is also 0.5. Precision and recall trade off each other. You can always get a recall of 1, but very low precision by labeling all examples with 1. A single measure that trades off precision versus recall is the F1 score, which is the harmonic mean of the precision and recall given by this formula here. The harmonic mean is a different kind of average, often appropriate in situations involving rates. Here's one way to think about it. Let's say you use your car to go from home to work, and you travel at a speed of X miles per hour. In the evening, you return the same distance, but this time with a speed of Y miles per hour. And let's say you want to know your average speed over the whole journey. So the average speed will be given by the total distance over the total time. And we know the total distance. Let's say the distance one way is d, then the total distance is 2d. And our time going to work is our distance d divided by our speed, x, and our time coming back from work is our distance d divided by our speed, y. And so we can continue to work with this expression, simplifying it to 2d over dy plus dx over xy, bringing xy on top. We have 2dxy over dy plus x. And here we can cancel d from the numerator and the denominator to give us 2xy. And I'm going to reorder these to get x plus y. And notice that our expression to get the average speed from the speed going to work and getting back from work is the same as our expression for the F1 score in terms of precision and recall. And that's what the harmonic mean does.